Hi everyone, my name is Shivangi and today I'll be talking about modeling opinion evolution in influence network, which is a time-varying logic framework for consent stability analysis. Basically, this project looks at how people's opinion change over time when they influence each other and how we can use logic math to understand if they will ever agree at any point or not. So let's start with the idea behind it. Every day we are a part of any kind of influence network, whether friends talking about politics or doing online discussion about various topics, or even discussion at work. People opinion shift depending on who they talk to and how strongly they are influenced by the people's opinion. But in the real life, those connections are always changing. We might stop following someone, or we met someone new, or who joins our conversation, or trust between the people changes over time. Most opinion model assume a static network, which is not true in real life. So my motivation was to build a model that actually accounts for those changes. So I made a time varying model which uses the logic-based tool to analyze whether people's opinion eventually line up or stay divided. So the main goal of my work is threefold. First, to build the time-varying model, one that allows influence connection to evolve over time. Second, to analyze when and how people reach consensus, or if some groups just never agree to a point. And third, to use logic to check certain behaviors formally. Things like, will everyone's opinion eventually be similar, or will disagreement always gonna remain? So it's a kind of a mix of maths, logic, and simulations, all mixed together to better understand how opinions behave in dynamic social system. To give a bit of background, the classic D group model is one of the first framework for studying opinion dynamics. It assumes people update their opinion by averaging what their neighbors think. Then we have Fredkin Johnson's model, which is based on stubbornness of a people. So, which and we have a one more model which says people only listen to others whose opinions are too different from theirs. So these models work well in theory, but they don't handle changing connection very well. Real networks are noisy, people connect and disconnect all the time. So my idea was to bring in tools from time varying systems and fit logics to not just simulate what happens, but to mathematically verify if system will eventually stabilize or not. Moving forward, alright, so here is a quick overview of the model. Each person or agent has a single number representing their opinion, let's call it xi, and each step they will look at opinions of their neighbors in the network and they slightly adjust their own. Now every person has a bias parameter which I will call B. This B value tell us how stubborn or flexible a person is. If the B is close to 0, that means they are very open-minded and they will adjust their opinions easily based on others and they are open to changes basically. But if B is close to 1, they are more stubborn. They will mostly stick to their opinions, whatever their belief is. So over time, the connection between agents, basically who listening to whom changes. That's what make it time vary. That's what my model was. So, but the Degroots model is just about averaging what others thinking. So it was the basic model which I have taken as a base model. So after that, the Frederick Johnson's model came in role, which had stubbornness, but the last one is time varying influence extension, which just updated version of Fredkin Johnson's model. It just have a time varying element in it. So keep the things manageable. I have made few assumptions. First, influence fate, or how much one person's affect another. are always positive and add up to 1. Second, over time, the network as a whole remain somewhat connected, meaning everyone is indirectly linked to at least occasionally. And third, we keep B between 0 and 1 when B is exactly 0, and when we get some weird edge cases like the people is stubborn will not consider anyone's opinion if B is equal to 1, or like the case where they are open to changes. So in most simulation I'm gonna use B between 0 to 1, but yeah, for just to check what changes will gonna come if we're gonna put the B between 0.1 to 0.6, so I'm gonna check for that as well. It give more realistic results and let us actually see opinion shift, so I'm gonna do that as well. You can actually see it in the plot. Each colored line is one person's opinion over time. When lines start far apart and then comes closer, that's consensus forming. When they stay apart, that's stubbornness or kind of a weak connection at place. It kind of cool just by changing over number for B, the entire group behavior changes. So these are the two simulations result from my code. The first one is for B equal to 0 to 1, and the second one is for B from 0.1 to 0.6. As when B is near 0, so everyone's super open-minded, opinions tends to converge pretty quickly. If the network stays connected over time, everyone eventually agrees to a point. But when B is higher, like around 0.4 or 5, you start to see more interesting dynamics. Opinions move slowly, and sometimes you get small cluster of agreements that never fully merge. So I have built the model in R. The code sets up a group of agents, build a time-varying network, and then runs the opinion updates. So step by step, I also added the option to change how often the network switches and how stubborn each agent is. Then it plots how everyone's opinion changes over time, and we can visually check if there is conversion or not. The next step is to add the logic part where we can formally ask or check questions like whether they're gonna just say the answer yes or no. So I'm working on that, just trying to find out how I can do that. Still in process. So in terms of tools, I have only used R for the simulation, and for the logic verification, I'm still looking for something I can use. The idea is run the simulation and collect the opinion trajectory and use the logic tool, some kind of a tool to test whether the behavior matches what we want, like stability, consensus, or oscillation. And this gives us both an empirical view and a formal mathematical guarantee as well, whether the outcomes coming are correct or not, the model is working the way we wanted it to be or not. For now, I've just used the R language only and its library to do all other parts, like for tracing the graphs I've used ggplot library, and the graphs which are generated from that I have just evaluated those only for to check the working of my model, whether it is doing correctly things or not. Alright, to wrap up, here is the big picture. So, as of now, I have developed a model that captures how opinion evolve in network that changes over time. I'm still working on it. There are still some changes that needs to done because I feel like my model is not working the way I wanted it to be. Still, there are some changes that needs to done. So, till now, I have checked how stubbornness affect consents, and we have saw from early simulation that the networks connectivity and the bias value B, both values are big role in how people align their thoughts and how they um, agree to each other's. The next steps are to do a deeper theoretical analysis on stability and integrate few more logic verification. So just to check few if we put any data in it, just to check whether the output is correct or not, and run larger simulation with more realistic networks and agents behavior to check it's working on larger scale of data. So that's all from me. Thank you so much for listening. I would be happy to take any question. Thank you so much.